Alright, next set of problems. We are going to look at the one where the object is dropped from rest from an elevated position of, we don't know. The act of dropping it from rest, you have to intuitively recognize that that's a velocity of 0 meters per second. Gravity's going to pull it down, so there's our acceleration. And then what we're told here is that 1.5 seconds later, that's when it hits the ground. We don't know how hard it's going to hit the ground. We don't know the value for delta y. That's unknown either, but delta y is going to be the key here to telling us how high that cliff actually is. So when I look at this particular formula, I have everything except delta y here. Let's put in 0 for these terms, so it's 0 times 1.5, but I don't need to write out the 1.5 there since it's 0 times it. This is negative 9.81, and then we put in the 1.5, and we square that value. And putting that into the calculator, what we should get is a value of negative 11 meters. That means it has fallen 11 meters, which means that the cliff had to have been 11 meters high. Next problem. We're going to take a look at someone that drops something from rest. It's going to go straight down. And we're going to compare it to someone that throws something downwards with a velocity of 10 meters per second. But because they threw it downwards, let's make it negative. That's also going to follow the exact same path. Straight down. However, those velocities are going to be different all along the way. What we're asked to do is find out what they are 2 seconds out. And what I'd like you to note, there's clearly a 10 meter per second difference between these two velocities. And let's use this formula to get our velocities at 2 seconds out, because we have VI, we have G, we have T. So if we do that, 0, negative 9.81, and then we have T being 2. Negative 19.62 meters per second is our velocity there. Next one up has a different initial velocity, so I'm going to use that same formula, but I'm going to put in my initial velocity of negative 10 plus negative 9.81 times 2, and what I'm going to get is negative 29.62 meters per second. 2 seconds out, there's still a 10 meter per second difference between the velocities. And you're going to find that you could try this 3 seconds out, 4 seconds out, any time value that you choose, you're going to find that they would still be separated by 10 meters per second. So my whole goal here was to show you that the velocity will grow at the same rate for each object, despite the fact that one of them was thrown downwards.